Hello everyone, it's my pleasure to be back again, this time with a session on best practices for securing web application infrastructure. So like most of my sessions, this is light on slides and heavy on the demo. For the next 45 minutes or so, I'm going to walk you through various steps involved in securing your web application infrastructure. So without further ado, let's get started. So if you have been following the series that Karan mentioned, we did deliver a session on what differentiates a production system from a dev test or a staging environment. Essentially, there are a few attributes that sets apart your production system or production environment from rest of the environments. Of course, your production system got more available, which means it has to withstand the spikes and actually maintain the same level of availability all the time. It shouldn't happen that when there is a spike, your application goes down and becomes unavailable, which is a very common scenario with web applications. But a production system should be immune to those issues and should be always available. And of course, your production system got to be very secure. This is a key differentiator when compared to other environments. And today's theme is all about security, but I want to continue the attributes that actually make a production system better and different from other environments. Of course, scalability, this is another important aspect. When the performance is demanding and when you have more traffic, when you have additional spikes and usage patterns visible, you got to scale your application infrastructure, and it should be done automatically. So instead of figuring out in the last minute what to do with your app servers or web servers, you need to have some kind of a well-defined policy that will automatically take care of your scale in and scale out operations. And those things can be automated. Similarly, performance, your application should perform exactly the same, whether you have 10 users or 100 users or 10,000 users. And that level of performance is very essential for delivering the right level of user experience. And finally, your application should be fault tolerant, which means there has to be a graceful failover mechanism when your database crashes or even the underlying infrastructure when it goes through outages and disruptions. You should have a very graceful mechanism to handle the user experience and make sure that you're not leaving a bad taste with your end users. So you need to have some kind of a mechanism where you're able to continue the experience even when you encounter critical issues with the underlying infrastructure or your own web application infrastructure. So these are the critical attributes that are essential for a production system. And of course, today's theme is all about security. So let's get started with the scenario for securing the web app. So instead of talking about the high level best practices, I thought I would actually start with an insecure web app and then walk you through the steps of securing it. So the app that I have chosen for this demo is one of my favorite applications that I have custom built, and it is called Cloud Shop. So let me first walk you through how it looks like and what I did with DigitalOcean to go live with Cloud Shop. So here, if you actually see, this is running in a domain called cloud-shop.in, and this is live. Any of you can access this. This is a live deployment running in BLR1 data center of DigitalOcean. This is basically an electronics portal that deals with cutting edge gadgets and the latest electronic items. You can place an order, you can browse the catalog. It's a full-blown, full-fledged e-commerce portal running on DigitalOcean. Though this looks pretty complete, there are some gaps, there are some loopholes that we have in this deployment. And as a part of this session, I'm going to walk you through plugging those gaps. But having seen the front end and the end user experience of this portal, let's take a look at behind the scenes deployment of the portal. So now switching gears, let me show you how I went about deploying this app. So obviously I have a database server running on Ubuntu in BLR1. It comes with 2 GB of RAM, 40 GB disk. It's a decent configuration to run an application of this kind. Then I have two web servers, and if you notice, they are launched from an existing image called Web Gold. This will help us quickly launch a pre-configured droplet instead of launching it and setting up the application. So this is another best practice, but that is not the emphasis here. The emphasis is more on how do we secure. So before we get there, let me also show you how I wire up these two web servers to a load balancer. So one of the recent additions to DigitalOcean services is a load balancer. So here I have configured a load balancer called Cloud Shop LB, and this is the front end, which is routing the traffic to one of the two servers. So you actually notice that both the web servers are registered with our load balancer, and it is forwarding traffic to the internal IP addresses. The health checks are also in place. So obviously, when one of the health check drops and the status goes unhealthy, the load balancer will not route the traffic anymore. So that's another level of defense that you can bring into your deployment. So we have the load balancer, and then I use a third DNS called DNS Made Easy, which is again one of my favorite third-party managed DNS services that I've been using for quite a while. So there I have gone ahead and registered my load balancer as the A record. So this is the IP address of our load balancer, 139.50.57. I bring this to DNS Made Easy, register my IP address here so that the domain called cloudshop.in is wired to the load balancer, and the load balancer in turn is wired to both the web servers, and that's how the entire workflow takes place. So when you go ahead and type the domain, DNS Made Easy will resolve it to the load balancer, and the load balancer will forward the traffic to one of the web servers. So far, so good. Everything looks like it is configured the right way, and we have the basic infrastructure, basic building blocks in place. Every time I have a show, all I got to do is launch another droplet, register it with the load balancer, and I have implemented scaling. So the basic hygiene is in place. But there are some gaps. Before we take a look at that, let's get back to the presentation, and let me visually summarize what you have seen. So there is a domain called cloudshop.in, which is pointing to the load balancer, and load balancer is pointing to two web servers, and the web servers are talking to a database. So this is the basic architecture we have in place. Now, there are 4 steps that I'm going to walk you through in securing web apps that are deployed on DigitalOcean. The very first thing that most of the customers don't take advantage of is the private networking part. So private networks are very unique in a sense that if you want to, let's say, replicate database between 2 instances, and if you are using a floating IP or the public IP address that is assigned to your droplet, essentially the traffic gets routed over the public internet. So that means even if you have deployed 2 droplets in BLR1 and you're replicating data between these 2 droplets, your outbound traffic from droplet 1 to droplet 2 goes all the way to the internet, gets routed back and talks to the droplet 2. So that's not a very optimal way of enabling intra-droplet communication. So the first thing that you need to do is to configure private network. Now, how do you do that? If you are new to DigitalOcean, when you're actually creating a droplet, one of the options that you will notice is called the private network. All you got to do is to click on that checkbox, and you'll be able to simply enable additional virtual NIC on your droplet. So here there is an option called private network. This adds droplet to droplet networking within the same region. Obviously, this is not a global network. For example, you cannot set up private networking between an instance running in NYC1 and another instance, another droplet running in BLR1. So that's not going to work. But within the same region, you will get better performance if you enable private networking. So this is actually a better way of securing your infrastructure, because if you're actually sending sensitive data, in most of the scenarios, most of the cases, we don't encrypt the data that is going out, because we assume it's an intra-droplet communication, and we don't really implement a very secure data transit mechanism. So to avoid the sensitive data going all the way to the internet and coming back, the best thing is to enable private networking. And once you do that, basically your droplets will assume a new IP address, which is going to look something like this. And this is the private IP address. So now this private IP address is going to be the chosen interface for intra-networking and intra-communication. For example, the load balancer will now talk to the web servers through the private IP. The web servers will talk to the database through the private IP. And we can force this further by implementing an A record in the DNS. For example, here I'm creating a record called an A record, which is db.int.cloudshop.in, and it is pointing to the private IP address of the database server. Now, the web servers that are actually configured, they are now talking to the database server through the private IP address. So the communication between the web servers and the database is routed via the private network. And the reason why we are using an indirection is, instead of hard coding the IP address, we are using a DNS entry here, because later on, if for some reason my database server gets killed or it crashes, I can bring up another database server, enable private IP address, and register that IP address with the record here, which means the web server will always talk to the database using the DNS name, which is db.int.cloudshop.in, but it doesn't know whether it is pointing to the old server or the new server. So very quickly, you can fail over with minimal downtime. So that is the biggest advantage of using a combination of your internal private network and using a third-party DNS for name resolution. So this is one of the best practices for using DigitalOcean for your production environment. It actually helps you in two mechanisms. First, it is obviously more secure because your data is now limited to the private network. Second thing is, you will achieve a level of fault tolerance because you're not hardwiring your IP addresses, but you are actually using your private IP address to talk to the instances. So let's actually see this in action. So what I'm going to do now is to grab the public IP address of my web server, switch to my terminal window, SSH into it. And now I have two choices to connect to the database, right? So I can actually ping the database by using its public IP. So I can do this, but when I'm actually using the public IP, remember, my traffic is routed via the public internet. Not a good idea. The other option is to grab the private IP and use that to talk to the database. This is perfect. But even better is actually using the record that we created in the third-party DNS. So db.int.cloudshop.in. So this record obviously is translating to the private IP address of the database server. And this is the advantage of using the DNS record instead of the IP address. So in my configuration, okay, let me show you how this actually looks like. So I wire up my database server to my web server by using not the IP address, but the DNS name that we created. And this DNS name is simply resolving to the private IP address. So that's one of the best practices that we strongly recommend when you are using DigitalOcean for production environments. All right, so let me get out of this droplet. So that was the first best practice. Always use private networks wherever possible. The second one that I want to highlight is a brand new feature called Firewall. This is just a month-old feature. It went live, I think, a couple of weeks ago, or just three weeks ago. And this is the new Firewall as a service offering on DigitalOcean. So what this basically does is it's going to bring a virtual firewall that protects your droplets from external access, from unwanted external access. So you can define both the inbound ports and outbound ports. And the best thing about the firewall in DigitalOcean is it is not tightly coupled to droplets, which means you can create a rule which is independent of droplets. You can apply some policies to it, like what are the inbound ports, what are the outbound ports, and then attach the firewall to a set of droplets. And all the droplets will automatically inherit the firewall rules that you created. So this is not tightly coupled, unlike some other platforms where you have to really do this at a very specific VM. This is going to be loosely coupled. So you define a set of firewall rules, and then you attach those rules to your existing or predefined droplets, and they automatically inherit the firewall policies. So let me show you the brand new feature of DigitalOcean, which is Firewall. All right, so now if you actually look at our existing deployment, one of the biggest gaps that you find is we are not restricting the external traffic. For example, if I grab this IP address, the public IP address of web1, and ping the IP address, it is resolving, right? So someone can very easily figure out, what is the IP address by looking at the domain, and then they can actually do a port scan. They can do a lot of stuff because we are exposing the droplet on the public internet, and there is absolutely no line of defense that protects our deployment. So the very first thing that we need to do is to open only the ports that we want to expose, right? So obviously you don't want to open all the ports. For example, on the database server, which is running MySQL, we can actually access this. For example, I'm going to grab this IP address, the public IP address, and guess what? I can actually run MySQL -h, give the IP address or the host name, followed by the username and the password. And guess what? We are right into the MySQL instance from the public internet, right? So if I actually do a show databases, you will notice that there is Cloud Shop database. This is my production database. It contains personally identifiable information. It contains my customer contacts, my customer details, whatnot. So not a good idea. This is one of the glaringly visible gaps in our deployment. Now, how do we protect this? There are two options for you. The first one is more complicated, where you need to secure every VM by configuring something like an IP table. And that's what we have been recommending earlier. But IP tables are very complicated, and it is not meant for beginners or novices. You need to have a very good understanding of the operating system, networking concepts, routing tables, ports, whatnot, even before you touch IP tables. But fortunately, with the managed firewall, you never have to deal with VM specific configuration. That means you'll never have to tinker with of your droplets to define your firewall rules. So if you notice, there are domains, floating IPs, load balancers, and firewalls. So this is the brand new addition to the networking stack of DigitalOcean. So let's go ahead and create a firewall. It's a pretty straightforward one. So I'm going to call this Cloud Shop Firewall. So we'll give it a name, and then we are going to define a set of inbound rules and outbound rules. So what do they mean? It's pretty simple. Firewalls can be of two types. The first type is open to be closed, right? What I mean by open to be closed is you need to selectively block the ports that you want to restrict, right? For example, port 3306 on my database server, I want to restrict it. So you can basically block and all the other ports are open. But the firewall that we are seeing here is by default close to open, which means the moment you apply a firewall, everything gets blocked, and only the rules that you mention here, the ports that you open explicitly, are going to be made available. So here I have SSH, And I know I can basically enable all the IPv4 addresses, which means anyone from anywhere can SSH into our box. But I don't want to do that, because enabling SSH for all the IP addresses is inviting trouble. So we'll actually get rid of this rule. I'm not going to enable SSH because I'm not going to expose it on the public internet. Instead, I'm going to expose HTTP, right? So let's make sure that our portal is accessible. So yes, our portal is still accessible, and we are actually able to SSH. So this was the SSH command that I ran previously into Web 1, right? Now we are going to apply a firewall. So what we'll actually do is block SSH and only enable HTTP. And we are also blocking the MySQL port, because obviously we are not opening port 3306, so that automatically becomes applicable. And here, all I got to do is add my droplets. So when I type web, it shows up web 1, then it shows up web 2, and then it also shows up DB. But for making the database attached to the firewall, I need to explicitly open the port, which is MySQL port. So I'm also going to do that. So I'll choose custom, and I'm going to choose 3306, which is actually the port meant for the MySQL access, the endpoint. So now we are not going to make this available to the outside world. Obviously, the database connection has to be initiated from the web servers. So I'm going to get rid of all IPv4, IPv6. Instead, I'm going to just type web 1, right, and web 2. So both of them have access to port 3306, and I'm opening up outbound traffic. This is fine because I don't want to restrict. I may actually do an automatic updates, or if I type app get update on my Ubuntu box, I need this. So we'll leave this as it is, but we have secured two things. One is we have disabled SSH on the public internet, number one. Number two, we just opened port HTTP, essential for our web server. For internal access, I have explicitly opened MySQL. So this is the primary step for me to secure my deployment. So now when I hit create firewall, okay, don't worry about it. I've been seeing this, but it still works. So now what we have done is we have basically configured the firewall, right? So now let's make sure that everything is intact. So I'm going to refresh this, and there we go. It still works. That means HTTP is not blocked. Then we try to run MySQL command that we ran earlier. Okay, oops, okay, I still have access to it. It shouldn't be. Let's go back and okay, technically this should only give access to web 1 and web 2, but let's check the SSH part. This is one thing which we'll revisit in a minute, but let's check the SSH part. Okay, now we are trying to SSH into web 1, and this is going to timeout. The reason is we have blocked access to port 22, which is SSH. Port 3306 is still exposed, but what I'm not very sure and what is surprising is I have enabled the sources only as web 1 and web 2. So technically speaking, I shouldn't be able to access. That's not a problem. We will come back to it. But if you notice, this is going to time out, and we have to wait for a while to see that error. But let's get rid of it. Now you actually know that we have blocked public access, and you can't even ping. For example, if you go back and try the ping command that we used earlier, now even this is blocked, right? That's because I have not opened an ICMP rule, right? ICMP port. So if I actually open up ICMP, just to show you how we can explicitly enable it. So this is going to enable ping, because ICMP is the protocol that ping client uses. So now in a few minutes, okay, something seems to be wrong. So hopefully that rule got created. Okay, ICMP is now enabled. So now when I actually come back and do a ping, okay, it is still not applied. I am encountering some issues with this. Never mind. So okay, I'm going to get rid of the ICMP. We don't need it anymore. All right. So let me make sure we have these things in place. All right. So that's fine. There are some error rates that we are experiencing with this, but it should be fixed very soon. All right. So that was the very high-level overview and introduction to Firewall. The third thing that I want to talk to you about is a very component that is called a jump box. So what exactly is a jump box, and how do you use that for secure access? So let me tell you the challenge we have now. So everything seems to be perfectly configured. We have select access to port 80 and port 3306. We have gone ahead and disabled SSH, but we have actually made this so secure that we can't even SSH into any of the boxes. That is a big problem. So if you want to patch, if you want to log in, how do you do that? You don't have like the master key to any of this. So disabling SSH is like locking your main door and throwing away the key. There is no way that you can enter your house. So similarly, we have disabled SSH on all this, and that's going to be a big issue. So what is the strategy that we need to follow to have secure access? Well, we are going to now create a gatekeeper, and this gatekeeper is going to have the master key to all the droplets, and he is going to verify your identity when you try to enter into any of the VMs. And the gatekeeper has explicit access to all these droplets. So a jump box is essentially that gatekeeper who will do a very thorough scrutiny. He will challenge you to prove your identity, and after that you can enter into the deployment to any of the VMs of your deployment. So that is what is going to be called as the jump box. So what I'm going to show you now is the end-to-end workflow involved in configuring a jump box. So let's go ahead and create a droplet. Okay, and this is going to act as our gatekeeper, which is also called as jump box. And this is going to be attached to a different firewall rule. So I'm going to use an Ubuntu 14.04. Since it's not going to run anything powerful or anything interesting, it is just an entry-level droplet. So we choose this. We are going to launch this in Bangalore 1. Enable private networking, and attach my SSH key to it. And let's call this jump box. Okay, so now we have everything that we need. This is just a gatekeeper, so we don't need to configure anything. So we'll go ahead and create this droplet, and this droplet is going to be our gateway to the deployment. It just takes a few seconds, and then we'll go ahead and authorize jump box to have access to all other VMs, all droplets. So let's first configure this. So what I'm going to do now is, this is not a part of the firewall, which means this is accessible over the public internet, and that's what we need. So at this point, I'll come back to the command prompt, SSH into my jump box droplet. Okay, and I will get into this just to make sure that the droplet is up and running and we have access to this. Perfect. So now the next thing that I'm going to do is to SCP my master key, right? Again, there are a lot of mechanisms, but I'm choosing the most convenient one. So my private key is actually called ID RSA. That's on my local machine. I'm going to copy this to my jump box. Okay. And now we have the key copied to the jump box. Okay. And I have to protect this. So we will go ahead and change the permissions of the private key and then move this into the .ssh move id.rsa into the .ssh folder of my root. All right, so now we have the key that we need to access our remaining droplets, right? So which are these. So jump box is now available on the public internet and these three are blocked. By copying the key, we gained access to all these three droplets through the jump box. Okay, so let's actually check if we are connected to this network. So web1.int.cloudshop.in, this is going to resolve the private IP address. Obviously, this is actually not able to ping because we have disabled the ICMP. So even internal network cannot really ping, but the good thing is it's able to resolve. That's all we want to check. Okay, now let's actually make sure that we are able to SSH into this. But guess what? We even disabled SSH for internal access. So we first need to open up SSH, but only for the jump box droplet. So instead of all IP addresses, I'm going to explicitly give permission to my jump box. So this is going to enable SSH access, but only to the jump box. Okay, let me do a refresh. Okay, so now we have given explicit access to the jump box on TCP port 22, which is SSH. Now, with the key in place and with the port open, I should be able to SSH into one of the droplets, right? So let me open another tab with all the droplets, grab the IP address of web1. Okay, this should technically work, but I have a concern that the firewall rules are not getting applied. The errors are indicating that something is not right. So let's give it another moment to make sure that the configuration is right. Yes, the source is jump box. Yeah, this seems to be fine. Let's try with the internal IP. Okay, there we go. I'm glad it worked. Okay, so now the interesting thing is when you try to log in from the public IP address, right, which is web1's public IP address. So when you actually say SSH root, let's see if this works. If this works, there is something wrong, but it shouldn't. So now I'm unable to SSH from my Mac, which is on the public internet, but I'm able to SSH into the same box through the jump box that we just configured. That's because we have given an explicit permission to the jump box for port 22. Now, if you are wondering, what if my jump box gets compromised? What if someone gains access to my jump box? Well, there is a pretty solid mechanism to secure that. So let's go ahead and create another firewall. So now we're going to create a firewall, and this is actually the rule for jump box. So we are going to create a jump box firewall. And here we are now going to disable everything, okay, and use SSH, not with all the IP addresses, but only a set of authorized IP addresses. So I'm going to first grab my public IP address so that I want to explicitly give. So this is my public IP address. If you're watching this in the recording, don't try this. My ISP or the provider doesn't give me a static IP, so this is going to be changed right after I restart my router. So don't worry about accessing my private network using this address. All right, so I got my public IP address, and I'm going to add that as a CIDR. So what this actually does is to provide SSH access to the jump box only from this IP address. So if you try to SSH into the jump box from any other network, the access is denied. You can't even access that. But from this network, which is my corporate network, that is secured, I can actually access the jump box. So now we have added another layer of protection, which is securing the jump box. So we are now watching the gatekeeper or the watchdog. So this is actually called the watching the watchdog. Jump box is like the watchdog, and now this is going to watch the watchdog, right? All right, so now let's associate the jump box droplet with this rule. Okay, so let's create the firewall. Now I'm going to ignore this. Hopefully it is now applied. Okay, so before my IP address is changed, let's go ahead and check this out. So I'm going to come out of the jump box and try to SSH again, right? So let me make sure I get the jump box IP address. So I grab this and SSH into it. There we go. Now I can very safely SSH into my other droplets. For example, db.int.cloudshop.in, right? I'll be able to access my database server that is otherwise restricted, but I can log in, I can patch, I can execute my maintenance commands, and I'm the root inside the DB. But can I access this from my Mac connected to the public internet? No, not at all. That's because we have explicitly given access to the jump box. So this is one of the best practices that you should immediately apply to your production deployments. And it will ensure you have a very secure way and a completely locked down architecture for production deployment. Okay, so that was the third strategy by leveraging the new feature of firewalls and also a best practice called jump box. So configure a jump box, allow SSH access to a select set of IP addresses. Perfect. The last thing that I want to show you is something which is considered to be basic hygiene. If I claim to be in the business of e-commerce, I can't even go live without an SSL certificate. But unfortunately, at this point, our portal is running on plain HTTP. So it's not even secure. So now I'm going to show you how we go ahead and turn Cloud Shop into an SSL enabled site, which will become more secure. So the data that is flowing between the browser and the website is going to be protected. So let me walk you through those steps. First thing, here you'll notice that Chrome is reporting that my connection is insecure, and I get that. I completely understand why it is happening, because we don't have SSL certificates attached to our site. So what we're going to do now is again leverage the concept of load balancers. So let me take you back to the networking services, choose load balancer, and on the Cloud Shop LB, we are going to now enable HTTPS. Right? So currently we have just one rule, which is a simple routing from port 80 of the load balancer to the port 80 of the droplets. This is very straightforward. This is a pass-through mechanism. But now what I'm going to do is point HTTPS, the port number 443, to my web server port 80. So I'm not going to secure every VM, which is going to be pretty complicated and inefficient. Instead, I want to offload the SSL termination capabilities to my load balancer. And this will ensure that the communication between the browser and the load balancer is completely secure, but the traffic between the load balancer and the VMs is going via the private network. So that is not of a huge concern to us. So we are going to terminate the SSL right at the load balancer level. So once we create this rule, we need to attach a certificate. So I'm going to click on new certificate, and this new certificate is going to ask us for a couple of PEM files, and this step is out of the scope of this demo. So basically what this means is you have to sign up with DigiCert or Symantec or any of the CA, the certification authorities, to get your SSL certificate. You have to buy them, and the certificates that you get are going to be embedded in this text box, which is going to be associated with the HTTPS port of your load balancer. The other option that you have is to go after a free service that is called Let's Encrypt, and you can use Let's Encrypt to generate self-signed certificates. It's not going to be really coming from a CA, but it is like a self-signed certificate pair that you can generate for your domain and bring those certificates into the load balancer. So let's go ahead and create this called Cloud Shop SSL. And then I have already generated these files: cert.pem, fullchain.pem, privatekey.pem. So these are the PEM files that I need to associate with my load balancer. To save time, I have already opened them in my editor. So let's grab cert.pem and paste it here. Then we need to grab the private key, paste it here. Then get the fullchain.pem and paste it here. So now we have successfully imported the complete certificate infrastructure into the load balancer. So now I'm going to save this SSL so that it is now wired to my load balancer. Perfect. Now I'm going to hit save and do one final thing before we test this in the browser. So there is one more setting, which is redirect HTTP to HTTPS. Setting this option will force all HTTP traffic to be redirected to HTTPS. This will only work if there is at least one HTTP and one HTTPS rule. So we qualify for this because we have configured both, and we want to force HTTPS over HTTP. And this setting is going to make it end-to-end, because even if the user is hitting HTTP cloudshop.in, he will be forced to get redirected to HTTPS. With that in place, we'll come back to the browser and hit refresh. And if everything goes well, okay, I need to do one setting which is very specific to my app, but don't worry, let's finish that. So from my jump box, I need to okay, just give me a second. I need to do some housekeeping here. So for that, I'm going to grab the jump box IP address, SSH into my jump box. And from here, SSH into my web1.int.cloudshop.in. Go to my config file and make one change where my default site is configured to be on HTTP. I need to update this as well. So this is a quirk that I need to fix in my app. So that's all I need to do. Now, unfortunately, I have to repeat this step one more time with my second web server. Okay, so config.php. All I got to do is just add an additional S to my URL and we are done. All right, so we get out of this and we'll come back and do a refresh. Perfect. Now you'll actually notice that green padlock and it says secure connection. In just a few minutes, I have gone from a very insecure deployment to a highly secure production deployment. And all of that is available to you through a few clicks and some basic configuration. So I hope you could follow all these steps that we have gone through, but I want to summarize them. So let's come back to the slide deck and let's do a quick recap. So there are 4 steps to securing web applications on DigitalOcean. First thing, enable private network to ensure that your traffic between droplets is taking place on a private network in a more secure form. Second thing is configure firewall rules and block everything. By default, the firewall actually blocks everything. So be very choosy, be very selective in what ports you're opening. And every time you open a new port, you have a choice to enable the traffic coming from any IP address or a set of droplets where if you remember, we have given Web 1 and Web 2 to DB. So the traffic originating from Web 1 and Web 2 targeting port 3306 is allowed. If the same port is targeted from any other IP address or droplet, it gets dropped. So that is the second one, right? So first one is open to all IP addresses. Second one is specific name of the droplet. Third one is very powerful, which I couldn't show, but if you are familiar with DigitalOcean, you understand this. So you can even give tags. So you can basically associate a set of tags to your droplets. For example, instead of adding Web 1, Web 2 manually, you can tag all your web servers with a group, web group. And then for the database access, instead of giving one droplet at a time, you can actually give web group as the tag, and any droplet that belongs to that metadata or the tag can now talk to the database. That is the third strategy. And this is highly encouraged if you are implementing automatic scaling in and scaling out. For example, every time you are bringing in a new web server, you have to manually register that with load balancer, because the load balancer has to route traffic to it. And then you have to manually add it to the firewall rule. So to avoid that, you should create a tag and then register the tag with the load balancer and firewall, not individual droplets. That will make your life easier and encourages automation pretty well. So those are the techniques for configuring your firewall and enabling secure access. Open to all, select droplets, or a set of droplets that belong to the same tag. So that's how we configured firewall. And you're highly encouraged to use a jump box, which is going to be your gatekeeper, and you will lock down access to a specific IP address that belongs to your data center. So no one can log into your production server in midnight and tinker with it, because they got to be in office. They got to be in the IP address that is whitelisted for the jump box access. And only that is authorized to touch the remaining droplets. So configuring jump box with select IP addresses and whitelisting them is a very secure strategy that you should adopt. And finally, the fourth one, the basic hygiene of running any portal. In fact, not just e-commerce, you should enable SSL for anything and everything that you're running, because Google ranking and its indexing algorithm is now prioritizing SSL over plain vanilla sites. So if you want to optimize your SEO and show up in Google results, you should actually enable SSL irrespective of whether you're running an e-commerce portal or a simple landing page. So how do you enable SSL? Pretty straightforward. Grab your certificates either from a CA or create self-sign through Let's Encrypt and attach them to the SSL and enable override. So this step will ensure that your deployment is completely protected, and it also helps you in your SEO ranking. So that's a summary of all the features we have touched so far. I hope you found this useful, and if you are a customer of DigitalOcean, you should actually take this as a prescriptive guide, go back and immediately implement all of them or at least a few of them to ensure your deployment is secure. And you have No excuses so far, because all the features that I have demonstrated are very implicit and available out of the box with DigitalOcean. So there is no excuse if you're not implementing any of this.